for this assignment, or for these notes, we are going to be able to use a calculator. So you'll want access to your favorite graphing calculator because we're going to be doing some linear regressions. If you're trying to do your assignment online, I will post another video as to how to access through CMS the TI-84 calculators and how to complete a regression on a TI-84. Okay? The first thing we're going to do, though, is we are going to review 8.3 because we just kind of barely touched on it, and it's something that we are already familiar with. So if I go to 8.3 on page 129 in our packet, regression and function fitting, using statistical regression to fit a function. This information, please do make sure that you read it, but this is stuff that you have seen before where we're looking at a scatter plot, and notice we don't connect the dots with little segments. We make one line that is called the line of best fit through the center of the data. Okay? And so we're looking for, if you were to calculate the distance between each and every one of these points and the line that you want is the one that's going to have the smallest distances with those points and that line. Okay? So that's kind of what your calculator is performing manually when you do this with your calculator. Okay? So we will be using technology to avoid some of the tedious math involved in trying to find where our points are going to have the smallest distance from that line. When you take your test, they will not require you to perform the regression. They will require you to be able to look at a regression and tell whether or not it's a good regression or not. So we will look at what that looks like. Okay? All right, here we have some important information about the correlation coefficient. When you run your regression on a calculator, you are going to get a correlation coefficient, and it is using the letter R as its variable, and that number will always show up between -1 and 1. If you end up close to -1, that means your data has a negative correlation. If you end up close to +1, that means you have a positive correlation. So you want to be either close to -1 or close to 1. Right in the middle at 0, the closer you are to 0, the less relationship you have. So your number will only fall in between these two. So you want to be close to -1 or close to +1. You don't want to be close to 0. So you're looking for something that's I would say 0.8 or bigger. So either -0.8 to -1 or 0.8 to +1. If you're somewhere in there, I would say that's a good correlation. Anything less than that and you're starting to become a weak correlation. Okay? So again, just to cover that, R greater than 0 is a positive trend, which means your data will be increasing. R less than 0 indicates a negative trend, so your data will be decreasing. And then again, the closer you are to 0, the more your data is scattered, the weaker your relationship. And the closer your R is to 1 or to -1, the data is less scattered, you have a stronger relationship. Okay? So when we look at this data on exercise 8.3.1 and we look at our data trends, we can see in the first one, you can tell all the dots seem to go in this uphill fashion. So that is going to be a strong, positive trend. Okay? When I look at the second one, I can see my data appears to go downhill. So this is going to be a strong, negative trend. And then when I look here at this one, my data is really scattered all over the place. So this one we would say no trend. Okay, or you could say neither. Okay, so strong positive, strong negative, and no trend. This also says to draw an estimate of a best fit linear regression function. So I am going to, on my number 1, I'm going to draw my uphill line. Again, notice it's not like a connect the dots situation. It's just drawing a line that kind of goes through the center of the data. So you can see that's an uphill line that would have a slope that's positive. And then for my number 2, I'm going to draw my downhill trend. Again, a nice straight line for my downhill trend. Okay, and then on number 3, since there's no trend, I can't really draw a line of best fit. If I tried to use this data in a calculator to get a line of best fit, then I would end up with an R that is very close to 0. It wouldn't be close to 1. Here I'd be close to -1. This one would be close to +1, and then this one would be close to 0 because I have a weak trend there. Okay? So now we're going to look at exercise 8.4.1, examples for linear regression practice. This activity should be done as a full class activity as a way for you to perform linear regressions on the relevant technology. So I'm going to show you how to do it in your Inspire. Okay? For problems 1 through 3, we're looking at this scenario. Various pounds of force are applied to a spring, which consequently stretches the spring y inches away from a reference at 0, 0. The data for this situation is located in the following table. So I can see if I don't have any weight on the spring, then it hasn't been stretched at all. And then the more weight I put on the string, or on the spring, the more that spring gets stretched, which should hopefully make sense. Okay? It says to make a scatter plot of the data and use linear regression to write a particular function that models this data. Okay? So if I look at the data, I can see that my x-axis is going to need to go all the way up to 80, and my y-axis is only going to need to go up to 24.3. Okay? So I'm going to actually use some scratch paper to sketch this scatter plot. So this is number 1 on exercise 8.4.1. And I'm first going to make my graph. My y-axis I know is all positive values from 0 to 24.3. I'm going to go in increments of, 6. 6 seems good to me. So I'm going to go 6, 12, 18, 24, and then I'm going to go 2 extra. All right, and then I need to go out to 80, so I'm going to go ahead and go by 10s so that I can get to 80. So 10, 20, 30, 40, 50, 60, 70, 80, something like that. So this is going to go by 6s, 6, 12, 18, 24. And then my horizontal axis, this is my y, my inches. My horizontal axis is going to go by 10s, 10, 20, 30, 40, 50, 60, 70, 80. And then we're just going to graph our plots. This is my x-axis, and these are my pounds that I'm putting on my spring, and these are the inches that the spring is stretched. Okay, so we know that if I don't put any weight, then my spring is not stretched at all. So 0, 0. Okay, 25.9, so just under 6. 30, 9.2. 39.2 is just going to be a little more than halfway between 6 and 12. 40, 12.1 is just barely above 12. 50, 15.3. 15.3 is a little more than halfway between 12 and 18, because 15 would be exactly halfway. 60, oh, we don't have 60. 80, 24.3. 80, 24.3, just above 24. So there's my scatter plot, hand drawn by me. Number 1 also wants me to use linear regression to write a particular function that models this data. Okay, so in my calculator, when I get a new document and I don't save the old document, we are going to go to lists and spreadsheets. Lists and spreadsheets. Okay, so the first thing we're doing number 1, we're going to go to lists and spreadsheets. Oops, that's too easy. Then we need to make sure that we relabel our columns X and Y. So up at the top where I have the A, I'm going to call that column X. I'm going to tab over and call the next one column Y. Okay, so the second thing, label columns X, Y, so that underneath I can fill in my table. Okay, so my X values are 0, 20, 30, 40, 50, and 80. And then just make sure that your Y values really line up. So 0 goes with 0, 20 goes with 5.9, 30 goes with 9.2, 40 goes with 12.1, 50 goes with 15.3, and 80 goes with 24.3. Okay? So then once I have my data typed in, then I'm going to go over to the side. Oops, I went too far. Off to the side in column C or D. I usually go over to D because I kind of leave a little space between my data and where I'm going to do my regression. And that's where I want to do my regression. So the third thing we did was we entered our data. And then now we're going to do our linear regression. So I'm going to hit menu, and I'm going to go to statistics. So menu, statistics. And we want to do some stat calculations. And we are looking for a linear regression. I usually like to choose the first one, that's mx plus b, because that's the way I'm used to seeing it, is mx plus b. So then I'm going to go linear regression. Unless I'm asked to do a different type of regression. So make sure you're reading, because sometimes it'll ask you to do quadratic or cubic. If you look at your data, sometimes it looks parabolic or exponential or cubic. Linear regression. And I usually go with mx plus b for my linear. And so then I hit enter, and then it's going to ask me, well, where did I store my x values? Well, we relabeled that column x. Where did I store my y values? I relabeled that y. Okay, so when I hit enter, I put x, I put y, and I hit enter, it gives me my linear equation. Okay, so the fifth thing we did was we said the x values come from x, and the y values come from y, and then we hit enter. So then, once we've done that, we can see our equation is mx plus b, and they told me what the m is, and they told me what the b is. So my equation is going to be y equals m is 0. I'm going to go ahead and round to 3 decimal places, 305 x plus b, but my b is a minus, so I'm going to say minus 0.04, and there's a 0 there if I want to really round to 3 decimal places, but I don't really have to write that last 0 there. Okay, so if I want to have it also over here, my linear regression is y equals 0.305 x minus 0.040 for number 1. Number 2 asks me what is the spring constant k for this direct variation. So the k, remember, if it's direct variation, y equals kx. So k is going to be the number in front of x. So k in this case is going to equal 0.305. Okay. And then number 3, what is the correlation coefficient for this linear regression? So I'm going to go back and look at my calculator, and you see an r squared, but if you scroll one more down, you see the r. And we're going to round this always to 4 decimal places. My r is 0.9999, which is pretty darn close to 1. Okay? So it says, what does this say about the strength of the linear fit for this situation? this tells me it is a strong, because it's real close to 1, positive trend. And if we look at the data as we graphed it, we can see that that looks really linear. Okay, that does look really linear. If you take, here's just another fun thing you can do. If, oops, oh wait, nope, I don't want a new document. I want the current document that I was working on. So we have this information in here, okay? If I were to open a new page, and on this page, if I go to data and statistics, notice it has all my data there, my little points that we made. I can come down here and say, well, let's make that my x's, because we named that x. So it's kind of fun because you can see the little dots all move. And so this will show you your spreadsheet. And I can say, make this my y's. Oh, look, it used the exact same things I did. 6, 12, it used 6's here and it did 10's here. And then from here you can also do menu. And you can say analyze, regression, and you can have it do a linear mx plus b. The problem here is it doesn't always give you your r value. Okay? So, and you'll need that r value, so you will still need to do the regression in your tables as well. Okay? And you can see that that line fits really close to every single, it touches every single one of those points. Okay? So it's a strong positive trend. All right, for the next data situation, we're still going to use relevant technology, and you can work on your own to perform the linear regression if you'd like to pause the video if you're watching the video. And then you can unpause and see if you ended up with the same information that I have. Okay? All right, so consider the following scenario. Taken from a classic experiment, the following table displays the number of cricket chirps, C, recorded in 15 seconds at various air temperatures, T, in degrees Fahrenheit. It's conjectured that this data is linearly related, so that when you graph it, it makes close to a line. Okay? So I have my number of chirps, and then I have my temperatures. My number of chirps and my temperature. Okay? I know this is going to seem weird, but the number of chirps is going to be dependent on the temperature, because the temperature is not going to change. Like the crickets aren't going to say, oh, I'd like it to be warmer today, so I'm going to chirp this many times to affect the temperature, right? The cricket has no control over the weather, right? So the weather is either hotter, so it affects how much the cricket chirps, or it's colder, so it affects how much the cricket chirps. So the temperature is my independent variable, which is kind of weird because usually we're used to seeing the x comes first, but in this table, if we think about our x's and our y's, the temperature is going to have to be independent because the cricket cannot control the weather. Okay? The weather does its own thing, as we well know here in San Antonio. Okay? The weather definitely does its own thing. The cricket has no say. All right, so make a scatter plot of the data. I'm going to use my calculator to do that. And then if you'd like to sketch one, you're more than welcome to. Now, I have this old data in here, and I want to have completely new data, and I want to completely start from scratch. So I'm actually going to go to the home screen, and I'm going to ask for a completely new document. I'm not going to save that. And we're going to, again, go to Lists and Spreadsheets. We're going to rename our columns X and Y. I'm going to hit the tab to go to the next one. And then I hit Enter and arrow down so I can input my data. Okay? Remember, your X is the second column. So as I fill this in, I'm going to be filling in from the second column. So 80.5, 70.5, 57, 66, 68, 72, 52, 73.5, 53. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm at 9. I didn't miss any points. And then I'm just going to make sure I didn't make any typos as I fill in Y. So 44 should be next to 80.5. 35 is by 70.5. 20.4 is by 57. 33 is by 66. 68 goes with 31. 72 goes with 35. 52 goes with 18.5, which is kind of strange. I don't know how a cricket chirps 0.5 time. 73.5 goes with 37, and 53 goes with 26. Okay, so all my data is in here. It says to make a scatter plot, so I'm going to go ahead and do that. I'm going to hit Control, Document. So again, I hit Control, and then I hit this Document button, and that's going to give me another page. Control, Document. And this time I'm going to do Data and Statistics. And there's all my dots, all just kind of randomly scattered because we haven't said where to put what. My X is going to go down here. Those were the temperatures. And then my Y is going to go over here. And if you ever need to draw your own, like when we did our fruit snacks activity and I asked you to pick your own scale, now that you have this tool, you can use this and it'll say, oh, here's a really good scale you could use. Notice it starts at 50, so it doesn't start at 0. That's okay. A lot of times what we do is we just draw a little squiggle in front of it so we know we're not starting at 0. Okay, so there you can see my data. Okay, does the data appear to display a trend? If you want, you can kind of sketch your data, what it's going to look like. Just so you have it, I've got like 1, 2, 3. I'm just going to kind of randomly sketch what this looks like. And then I've got like, 2 kind of together, and then 2 real close together, and then 1 right here, and then 1 way up here. Okay, and so number 5, does this data appear to display a trend? Well, to me, it looks like it's going uphill, and it does look to be rather linear. So I would say, yes, the data appears to have a strong positive linear trend. Okay? All right, so now we're going to perform that linear regression on the data. So from here, I actually want to, because I'm going to want that R value. I could do it here and see the line, but I want that R value, and I won't get the R value from here. So to go back to that last tab, I'm going to hit Control, and then I'm going to hit the left arrow here, and that'll move me back to the last tab. I'm going to go over to column D and go all the way up to cell 1. You don't have to put it there. You can put it really wherever you want, just not in A or B, because everything in A and B needs to line up or you'll get an error. Menu, Statistics, Stat Calculations, and we're going to do a linear regression with MX plus B. I've got X, my X list comes from X. My Y list comes from Y. I just hit the down arrow to go down to the next one. And then I'm just going to hit Enter twice, and it'll give me my linear regression. Okay, so perform a linear regression on the data. I'm going to write down what that answer was. That equation is Y equals my M, 0.791 X plus B, but my B is negative, so minus 20.974. Okay, there was my B. Okay, it says right there, your comment on the appropriateness of the result and the regression equation. So there is my regression equation. So when I look at the result, I can see that my R value is 0.9509, so that's pretty close to 1. So I would say it is appropriate because it's close to 1. Comment on the appropriateness, it's appropriate. We wrote the equation, and yes, the data is linear. If it wasn't linear, we wouldn't get a strong positive R value there. Okay, we wouldn't get a strong positive R value. right here. Okay? All right, so what is the correlation coefficient for this linear regression? What does it say about the strength for this situation? So this is very similar to the last question, except that this time they want me to write down the R. We're going to round to 4 places, 0.9509. And what does it say? There is a strong positive trend. Okay, so there is my exercise 8.4.1. Exercise 8.4.1. Okay, and tomorrow we will begin looking at 8.4.2. Thank you so much for watching.